next challenge was mokerview. This was a 500-point challenge. Only 3 people solved it. It says your classic bug combo pack. Admin will visit your URL after logging into it. We're given a Python file, a netcat port, and the website. Again, I did not solve this challenge. I used the write-ups written by the challenge author, which can be seen here. It's Seraphin. The full URL is here. Seraphin also helped me a lot while trying to get this exploit running. It turns out there was a unintended solution that I think all the teams that solved it ended up using the unintended solution. So this write-up covers the intended one, which we're not going to be doing. We're going to be doing the unintended one, which makes it a little bit easier. In the intended solution, you're supposed to do a timing attack for the final stage to overwrite a session, but instead we're going to do a CSS injection to leak out the flag URL. Anyways, so what we're going to do is we're going to take a look at the website, then we'll look at the Python file, and then we'll go over the solve script. So actually, let me log out. This is the website, mokerview, web, chow, irisCTF. So you can register or log in. So let's register, BB, then we can log in with that, BB. Make this a little bit bigger. So these mockers, it could be mokers, I'm not sure how to pronounce it, are images of this cat, and you're allowed to add mockers to your profile. So we can add the cat of the day, the mocker of the day, and it's this cat. There's a couple other things we can do. So we have my mockers. We can add a new one, and there's a collection of them. There's one called the flag one, but we're not allowed to add this one because our username isn't admin. But we can add all these different mockers, and I think they're all the same URL. We can also create a new mocker. I didn't play with this, but so you can add a name and a imager path, and you can also remove a mocker from your profile. There's one other feature that's super useful. This is you can style it. So they have this funny styling, or this one, and you can see it's doing a relative offset to some CSS. So already we know what the goal is. There's some flag mocker, so some image that has a flag, but we're only allowed to add this to our profile if we're the admin. Cool. So this is the source code. Cool. So we have the flag mocker. So this is the name of the mocker, and this is the imager URL token. So they construct the URLs. Here's the code to construct the URL. It's just i.imager.com with the mocker. So this thing. So there's one flag mocker. So somewhere there's an imager URL that has the flag, but we just can't see it. There's an admin password. There's a user already with the name of @admin. They by default don't have any mockers. We're going to have to, during the exploitation phase, we're going to have to fix this. There's content security policy, a very restricted one, so there's no JavaScript, and you're only allowed to load images from here. It still means, though, I guess I shouldn't say it's very restrictive. It's very restrictive for these, but there's no default source or anything, so you're still allowed to load fonts and all that stuff in CSS from anywhere, objects. So I think technically, if you have object source, you essentially still have a script. It's not script, but you're still able to get execution, but we're not going to be abusing that. Next is, so there's the session objects, and it's just cookie.getSession. We'll talk more about that in a bit. This app uses a lot of CSRF and CSRF tokens. We'll be talking about that. Eventually we're going to do a hash extension attack, and you can kind of see that here. So when you log in, you generate the 16-byte key, and the query, this is the URL query, is hashed together. And so, if you do key and then known plain text, you can actually extend this hash. Oops. So that's one part. Like I said, this challenge was a stringing together a whole bunch of different bugs. Next is the signer. This is related to the CSRF tokens. So this is the thing that generates the signed URLs that you can then use in the future. So an example of it is here. So this is the script that generates the header of each file, and we can see it's going to sign this URL. And so when this is done, I think it'll be like token is equal to, and then it'll be some big hex value, and that's your CSRF token. Cool, couple routes. There's a home, some static path. At first I saw path and I was excited, but Flask does a good job with send from directory. There's register, nothing too exciting. It's going to make sure it matches this pattern, and it's somewhat restricted pattern. Well, there's not much you could do anyways, but just uppercase, lowercase, and numbers. Where we register, and then it just saves it, plain text. There's login, more login. So the intended bug, one of the intended bugs, used something an issue in here, and so it'll grab the username, it'll grab the password, it'll check if the user exists. If it does this interesting thing where it'll get the existing session ID, and if that session ID already exists, it'll reuse it, which is a little bit strange. But using this, and the fact that this route doesn't have CSRF protection on it, so there's no CSRF decorator, function decorator, means that you can force login someone, so they'll have one session ID, and then you can force them to log into a different account, and it'll reuse the same session ID. And this is useful if, like, for a timing attack. So if you're, doing something with this, and then, session ID, I think it goes, the attack, we'll see it later, is like, if this is true, like, it might bypass this logic, and then later we'll reuse this within the same function, and we can change it behind the scenes. So anyways, that's the timing attack. We don't end up exploiting it, but we'll talk about that a little bit later. There's a logout. Here's the view function. We're going to find our first, another bug in here. So styles. So we're doing a request get arg, so the style parameter, and you're allowed to, you have an injection at this point. So we can see href is equal to style. Style has to match style pattern. Oops. But if we look at style pattern, we see that there's a bug. We have A to Z, 0, and there's an accidental space here. I mean, intentional, but, we're supposed to find this bug. So because of that space, we can go anywhere from space to 9. And so that allows quite a few characters. Let me make this bigger. So we have the space character, and then that goes all the way to 9. So specifically, that includes this quote character, which is super useful. So we can do a dangling injection attack and leak some stuff, which is another bug we're going to use. Going down. And we're actually going to use this bug twice. Once for the dangling attack, and once for a CSS injection to grab out image URLs. There's this great method. I didn't end up using this, but I think there might be another solution that involves this. But basically you can add other images to the global object. Let's see, there's the add method, which we will also be using. So this is how you have an account and you want to either add the mocker of the day or you want to add a specific mocker. And we can see here's the admin check. So ideally we would like to add the mocker of flag mocker, but it checks that if you want to add that specific one, you have to be admin. Like we said earlier, there was that timing attack. And so the intended solution for that timing attack was you're supposed to have the admin make a request to add the flag mocker, but this, at some point, there's going to be request.get the mocker. This is going to take a second, and while that's happening, you CSRF login the admin so that the underlying session user changes. So I guess it's like a time of check, time of use bug. And so by the time it gets down here, session user will actually point to an account you control, and so it'll add the specific flag mocker. We didn't end up using that bug, but that is the intended solution. There's also delete and delete. Cool. So let's take a look. There's two bugs I want to talk about specifically. The first one is this one. Yes. So, like I said, we're allowed to add custom styles, and there's, because of, this is kind of nasty, to add delete that. Because we're allowed to inject quotes, we can do quote and then // and a URL we control, and this will inject that URL so that into that href, and so this is just like a schemeless href, so I think it just matches the scheme of the current origin. And because we have that quote and there's no other quotes, we get a dangling injection attack. And so we can see that this href, it's going to load the domain we control. So ngrok token leak is the name of the URL, and you can see it's including all this stuff that it's not normally supposed to include, but because it's looking for another double quote, it's just going to keep eating this content. So we get a logout, args, and token. So we have a logout token here, which is useful. It keeps going. We get all this stuff. A delete token, a delete call, and we specifically like this one. So this is a action is add. The args is the token of the day. The mocker of the day, and it has this csurf token. So when we leak this, we can actually do a hash extension attack on this. I think the URL is something like add. It's like daily equals 1 or something like that. And we're going to instead do mocker is equal to mocker flag. And if we look at the logic for add, we can see first it'll check and see, it just daily needs to be true, and then it'll add that mocker of the day one. If not, so this is normally the case that happens because mocker is not defined. But we're going to do a hash extension attack, include mocker, so both of these are defined, but as long as mocker is defined, it's going to ignore daily. So we do the hash extension attack, include mocker, and then we're going to include the flag mocker. But anyways, so using this dangling injection attack, because we're allowed to include the quote because of the incorrect regex, we can leak out this token. So we have the csurf token. Because the csurf token was doing secret and then URL, we can do a hash extension attack, and now we can csurf a admin account into adding a flag mocker, or we can csurf them into doing a bunch of stuff, but we can specifically csurf them into adding the flag mocker to their account. So anyways, that was one bug I wanted to talk about before we go over the full exploit chain. The other bug I wanted to talk about was we can manually inject CSS into it too. So if we provide a valid link, we're allowed to inject CSS. This is really cool because we can do the unintended solution, and that is a cross-site scripting injection, and we can exfiltrate the URL byte by byte. Cool. Actually, I'll talk about the full exploit chain, and then I'll go into a little bit more details on this one. So our full exploit is, if we go back to the challenge, we have this netcat that we can use to submit a URL. The admin will visit the URL after logging in. We know the challenge involves a bunch of different bugs, but it specifically looks like there's something related to csurf, and there's this image URL we need to steal. So we're going to do the exploit in a couple of steps. The first thing we're going to do is, let me look at this. I'll cover this document twice, but first thing we're going to do is we're going to leak their token, then their csurf token, then we're going to do a hash extension attack, then we're going to csurf them again, the admin, into adding the flag mocker to their account. Then we're going to csurf them, I guess it's kind of a csurf, we're going to csurf them, it's not really csurf, but we're going to have them load with our custom CSS and do a CSS injection and exfiltrate the image URL using CSS selectors. Cool. So this is what the actual solve script looks like. There's two things. There's a solve server and there's the index.html. I'll kind of go back and forth between both of them. But like I said, let's start here. I think this is the actual page that the bot is going to load. So we define two variables. We do a fetch request just to reset the server every time, because I saved some internal state. So like I said, the first thing we're going to do is leak a token. So we are going to make a request to the mocker host, so the website URL, view, style, and then this URL called token link. And there's this dangling quote here. So we're setting this into a form element, and then we're going to do a submit. And so that form element is just defined up here. Technically, actually, I don't need this parameter. I put the parameter here. For some reason, I can't put parameters on the form. I wasn't really sure why. I was also doing this with an iframe, but the cookies weren't being sent in an iframe for some reason. I guess, some sort of safe site stuff. So I had to use a form. Anyways, so we'll get that token leak. And so the web page, so the admin is running in probably a headless Chrome. It's going to go to the Mocker website. It's going to load that fake CSS that has the dangling injection attack, which will eventually call back to this route. From there, we can split out the token, and we'll save the token to CSRF token. Cool. So now to step 2, we're going to add the flag mocker to admin. So I fetch the new updated token from this route. And so we have the previous CSRF token. We're doing a hash length extension. Our current contents of the hash is secret plus this. We know the secret is 16 bytes, and we want to add mocker equals flag mocker. So we do the hash extension. The contents are a little bit different, so I just do a manual decode right here. But this is what the new website URL contents will be. We base 64 this because there's an args parameter. It's not that exciting. And then we construct this redirect URL, which has our arguments. So this is the add daily1 mocker equals flag mocker with a bunch of stuff in the middle. Thankfully, that is accepted by Flask on the other side. Is it Flask? Yeah, I mean, it's this mokerview server, so it's accepted by Flask, and the token, which is our new CSRF token. Cool, so we did the hash extension attack, so we're going to have the admin also submit this on behalf of themselves. So they're going to add the flag mocker to their account, and it's going to do another submit, and then we're going to wait a second. And then this was my favorite part of the challenge, even though it's the unintended solution. It's just my first time doing one of these CSS injections. So now now the admin has a single mocker in their account. So they're going to be like this. And so this one would be the flag mocker on their account. And this is all they have. And so what we're going to do is, let's inspect. So we have down here, so we have this image source. We're going to do a CSS selector on image source, and we're going to match some fun stuff. So we're specifically going to try and do an image where source is equal to something like this. Actually, this is normally what a CSS injection would look like. Imager.com/a, and then we do content, and we'd say URL, HTTP, attacker.com, leak equals a. And then we generate these for A, B, C, D, E, F, G, H, I, J, K. So, and it's cool because, so this would be B, like I said, C, and this would be A. And you're going to do this character by character. And so, like I said, it's going to check and see if there's an image with a source, and if it does exist, it's going to replace the content with this URL. And this will trigger a page load on our web server, and then we can record what happened. After this is done, we do another attack. Let's say it started with a queue. So then we do QA, QB, QC, QD, and we do it character by character. Super cool that this actually works. I mean, it's bad overall, but it's pretty fun to write the exploit. But there's a couple problems with this. First off, there's content security policy on the page. So we can't load images, which made this a lot harder. And this is where I got a lot of help from the challenge author, trying to figure out how to make this exploit work. We knew it was possible because the challenge author was pretty certain that the 3 people that solved it all did a variation of this. But it's kind of hard. Like, we can't load images, and most of the remote URL are images. So we tried, you can't do import is another construct for like loading, some CSS, but import has to be at the very top of a CSS file. So you can't do it inline like that. I tried to load like other styling from different mechanisms. I couldn't get anything working. Eventually what I found was you can do fonts. So you can define a font family. I think I might get this wrong. I think, or is it font base? I think it's font base here, and then font family. And we'll call this font a leak. And I think you can, is it content maybe? Let me check real quick. Not that one. Network. Source URL. So you would do source and then URL and where to load that font from. so we would load it from this. And what's cool, oh, sorry, and then we go over here and we would say font family leak A. So if this matches, it will then request that it uses the font family leak A. And because this does lazy loading, then it'll look for leak A, it'll see this font family, and it'll load the font from here. And then we get a leak that A matches this A, and so we know what the next character is. But there's another problem. When you match on this, there's no text being displayed, and so the font isn't loaded. So we need to go a little bit further. So instead we do body, then I think it's, is it has an image, and then we do before font family, then we can do a content on this, and we just insert some text. And so now what's going to happen is we're looking for a body tag, which is just, there's only one, that has an image that matches this, and then before the body, at the very start of the body's inner HTML, is going to inject this content, which is text that we then want it to load with this font family. So this took a while to get. Again, lots of thanks to Seraphin for helping me figure this out. But yeah, so we can generate for those for every single letter, which is what we do right here. So this is an example of the exploit being loaded. We can see font face, font family, leak A, the URL to call to load this fake font, and then that's if body has image source before, font family, leak, border, and then some content. And you can see the content's being injected right here. Another tricky thing is, I mean, it's not that tricky, but font families are case insensitive, so you have to do one for, I put a U for uppercase, just to make sure you get rid of that case insensitive thing. Because otherwise you leak both D and lowercase d, and uppercase D on a single, on the very first character. Cool. Anyways, I think that's everything. Again, a very useful resource I found was this HTTP leaks. It's a huge list of every way that your browser might leak some URL or some information. Again, it's all images. I couldn't find anything that wasn't an image, except for that font exploit. But definitely bookmark to this. I think it's by Cure53. So, cool. Well, I think all that's left is to see if the exploit's still running. So, like I said, we leak character by character. To do that final step, we just send it this mocker style with the ngrok and CSS. And if we look at the solve script, leak is the font handler. So, and when you call leak, you do it with C is equal to like A. And so I grab that A and I add it to what I think the current URL is. And so it just appends character by character into this global variable. And then this is the route that grabs the CSS. So I just find that global variable, and then I add the next character, all the characters. So lowercase, digits, and then uppercase. And the uppercases are different because I do that I signify it's uppercase, so I get rid of that case insensitivity. Cool. Let's see if it works. I want that. And this. Let's get rid of it. Get rid of that. It's reset. So we should be able to netcat. Then we go to the ngrok port. What is it? That one. Let's reset it. We'll put it in. So it should start hitting. So it reset the server. We grabbed the token out. We did a token leak. Then we did a CSRF. We added it to the Mocker's account. You can see this is the add. So the contents of our new CSRF hash extension attack. That's the new contents. That's base60 forward. This is our new CSRF attack for CSRF token for adding the flag mocker. And then we're doing the CSS link. So this is the URL that redirects with the new flag mocker call. Then it loads the CSS with an empty matcher, which is just i.imager.com. We get a leak of character L, and so you can see the L, it's printed here. Then we run it again. We do get CSS on a new page load. it leaks n, so we know the first two characters of the flag are imager.com/ln, then lnv, lnvr, lnvx, blah, 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 and then 88. And so if it worked, this should be the flag, and here we are. So super cool attack. It took me very long to exploit it, but very, very cool. I'm excited I finally finished it. And again, thanks to Seraphin for all the help in setting up the challenge, and the rest of the irisec people for putting on a great CTF. Anyways, thank you. See y'all.